382 in your books. Look what it says. It says you deposit $500 in an account that pays 6 7/75% interest, compounded continuously. And then it says, how long will it take your money to double, and how long will it take your money to triple? Okay. Now, we've had one new formula about compound interest since your second test. Okay, so on your second test, you had simple interest, all right? And then you had compound interest. So your projects, I hope, helped you get the compound interest, where it was compounded quarterly or monthly or whatever, all right? But on your third test, there's a new formula. And this is the one for compound continuously. So compounding continuously. We talked about this, and it's been on that video. So make sure that you kind of learn that formula. So they reiterate it on page 382. So it's A equals P, then you've got an E. What are your powers on your E? An R and a what? Look on page 382 and tell me. T. Now, some of these variables are the same. What is your P in that formula when we're doing finance? What's that P? The principal. Is that the beginning amount or the end amount? Beginning, okay? What's that A stand for? That's my future amount, isn't it? So that's the same as it was in those formulas from test 2. P is the beginning amount, A is the end amount. Okay? Now here's what's a little different. You've got an R and you've got a T. Now, you've seen R and T before in simple interest, right? And in simple interest, we said they just had to match. Well, for this formula, R is your interest rate, but it needs to be in years. And this T is your time, but again, it needs to be in what? Years. Okay. Now remember, the other interest form with compound had I's and N's. And it was, if it said compounded monthly, you had to turn everything into months. If it said compounded quarterly, you had to turn everything into what? Quarters. But this says compounded what? How are you going to turn everything into continuously? You see what I'm saying? You can't really do that. So instead, we turn everything into what? Years. So if they said 18 months, I have to change that to 1.5 years. Okay? Now look what the question said. The question said you deposit $500 in an account that pays 6.75% interest. How long will it take your money to double? Now, what is the 500? Is that your beginning amount or your end amount? What's that 500? That's the beginning, isn't it? What's my interest rate according to that problem? On page 382, that example. What's my interest rate? All right, it says 6.75%. Does it say per anything? Then it must be per what? Per year. Remember, when it doesn't say, it's got to be per year. Now it says, how long will it take for your money to double? So aren't they asking you how long? So we don't know the time, but it wants my money to do what? Double. All right. So if it was 500, what would it be when it doubles? It'll be 1,000. So I'm going to plug all that into my formula. All right, so what's my A? My future amount is what? 1,000. And my beginning amount, my P was what? 500. And we have E, and our rate, now our rate is 6.75%, but I got to change that to a decimal. What's that going to be when you change it to a decimal? Point what? 0.0675. And then I've got it T. Everybody okay so far? Now, aren't I trying to solve for this variable over here? Well, let me ask you this. I need to isolate it then. Now, what's over here that I've got to get rid of that I don't need? That's already down. What have I got to get rid of? Okay, how can I get, what's this 500 and this E? Are they added, multiplied, divided? What's that mean when there's nothing between them? They're multiplied. So how am I going to get rid of that multiplication of 500? What am I going to do to both sides? So if I divide this side by 500, I've got to divide the other side by what? 500. Because I'm trying to isolate this thing right here because it's where my power is. Okay? So what happens to these two 500s? Don't they divide out? So that's going to leave me E raised to these two things, 0.0675 T. Isn't that number times T just that number in front of T? Now, what's 1,000 divided by 500? 2. Okay, so is everybody tracking with me? Now, isn't it the same problem I've had before? My variable's up here is a power. So what am I going to do to both sides to help get it down? Take the natural log. Someone take the natural log of this side. I'm going to take the natural log of this side.
You pull that exponent in front.
That's right. So everybody can see what we did. Now, like Tucker said, what's he going to do now? Since he's got the natural log of both sides, what can he do with that power? He can move it to the front. Now, you may not need your calculator for this part. You may have learned it, but if you haven't, punch your calculator. What's the natural log of E? That's just 1, isn't it? And what's anything times 1? It's just that thing right there, isn't it? Now, I'm just going to not waste the marker. You can go to another line, but that just goes away. Right? Okay, how do I get rid of this 0.0675 in front of this T? What have I got to do to both sides? Divide by. So I've got to take that side and divide by. Okay. So again, those go out and just leave me what on this side? T. All right, you've got your calculator, so type in the natural log of 2 divided by that number, and let's see what we get. So the natural, if I can turn my machine on, the natural log of 2, and then I'm going to divide that by 0.0675. You get about 10 point maybe, what would that be? 3, 2 or 3? 3, because we're not going to chop it off, we're going to round it off, because isn't it 2 and then a 6? So wouldn't it make it go up? Now, what time is this in? What was the interest rate in? It's in years, right? So what's the time coming out in? Years. So it'd take about 10 years for my money to double. What if they wanted the money to triple? Well, then instead of being from 500 to 1,000, it'd be from 500 to what? What's triple 500? 1,500. Everybody okay? All right, let's look at another one that's a little different. All right, look on page 383 of this example 11. All right, look what it says. It says hospital expenses. From 1997 through 2008, the yearly expenses, Y, in billions of dollars of hospitals in the United States can be approximated by, and they give you a little formula. Where T represents the year, with T equals 7 corresponding to 1990 what? 7. Everybody with me? It says use the model to estimate the year in which the expenses of hospitals reached about 610 billion. All right. So they give me a little formula that looks like this. here's my formula. Y equals 208.05 E raised to the 0.067 T. Now, when they give you a formula, it's really important that you know what the letters stand for. So go back and read. What is Y in this formula? Go back and read in your book. What's Y in that formula? We need to make sure we bring our books. You're going to start getting lost. We're going to do a lot of word problems. It's my hospital expenses, isn't it? But it's not just my hospital expense. It's my hospital expenses. And what does it say? Does it say in billions of dollars? So what if Y comes out to be 3? Does that mean $3? That means 3 what? Billion. That's a big difference. Okay. Now, what's that T? It says use the model to estimate the year in which the hospitals reached about 610 billion, right? So do you understand that that T is your time? And then notice what it says in the problem. It says T equals 7 corresponds to what year? What was it, 2000 or 1997? What was it? 1997. Because that's going to be real important. What if T was 8? What year would that be? 1998. What if T was 10? 2000. That's right. So we got it because when it comes out, we got to know what we got. Now look what it says. It says use the model to estimate the year in which the expenses reached about 610 billion. Now, in the 610 billion, the expenses. So in my formula, what's my expenses? Y. Now, I'm not going to put 610 billion. I'm just going to put 600 what? 10, because it said that that's in what? Billions. And they do that a lot of times so that your calculators will take the numbers. Because if you start throwing billions in your calculator, it starts like dying. So I've got 610 equals 208.05 E raised to the 0.067 T. Now, aren't I looking for time? So again, in my variable up here is an exponent. So I'm going to have to get it down. Is everybody with me? So the first thing I'm going to need to do is I'm trying to get this thing by itself. Because once I get that thing by itself, can I take the natural log of both sides? So what have I got to get rid of first? This number in front. All right, how do I get rid of this number in front? So if I divide this side by that number, I've got to divide that side by that number. So does everybody understand the point? You've got to get the number raised to the variable, you've got to get it by itself. So if there's other stuff over here, get rid of it first so it doesn't get too complicated. Okay? Now those 208s are going to go out. So on this side, I've got E to the 0.067 T. And then let's just divide those. Okay. So we've got 610 divided by 208.05. Right. See if you got about 2.9. Is that what y'all got? Now, I've got a number raised to a letter. So as soon as I get a number raised to a letter by itself on one side, what do I do to both sides? Take the natural log. Very good. I'm gonna take the natural log of this side. And I'm gonna take the natural log of this side. Everybody okay so far? Now, once I take the natural log of both sides, what can I do with this power? Pull it where? To the front. And I'm going to take the natural log of that side. And I got about 1.075680522. See if that's what y'all got when you punched it in your calculator. Is that what y'all got? We okay? Now, what's this natural log of E? You probably remember by now. What's the natural log of E? 1. So doesn't that just kind of go away? Because 1 times this is just going to give me this, isn't it? So that natural log of E is just 1, and 1 times that is just that. Now, how do I get rid of this number in front of t? So if I divide this side by that number, I got to divide that side by that number. Okay, so let's see what t ends up being. T is about, let's see. Did you get about 16? Now, look why this is not exactly the right answer. I mean, it's not that it's wrong, I'm just not finished. So it takes about 16 years, but they didn't ask me how long it took. They asked me what year it was, right? So help me out here. I've got to add 16 years to 19 what? 97. So what year is that going to get me? About what year?
2013.
2000 what?
13.
Let's double check. Now let me show you something. I'll show you why we've made a mistake. You say it's 2000 what? 13. But now look, if t is 7, that's 1997. What I want to know is what is t when you add 16 years to it? In other words, this isn't 0, this is what?
Negative.
7. Is everybody with me? So when t is 16, that's not really 16 years past this one. That's only how many years past this one? 9 years past this one. Does that make sense? They said t was 7 in 1997. What did we get t to be? We got t to be what? 16. So I didn't know what year that is. So you told me a minute ago when I said when t is 8, you told me it was what? 98. You told me when t was 10, it was 2000, didn't you? So what is t equals 16 going to be? The answer is 2006. So we've got to make sure we go back. Remember we talked about before, over and over, Polier's last step is one of the most important steps because we nearly added 16 to this, but that would only be true if that was when t was what? 0. Everybody with me? So always go back and double check. So what you're going to do for homework is nothing new, but you're going to do it with word problems. So let's review real fast. All right. So the first thing they're going to do is give you some formula, probably. They're going to hand you the formula that's going to have a power for the exponent. So the first thing you need to do is you need to isolate the number that's got the exponent power. Sometimes it's already by itself. Cool. If it's not, though, you got to get rid of everything except the number raised to the letter. So when you have the number raised to the letter on one side by itself, what are you going to do to both sides? Take the what? The natural log. And then you're gonna use that third natural log rule, which says you can take that power and do what? Pull it down front, and then you're back to what you think of as a regular algebra equation you just solve for that variable. Okay, where's your homework gonna be? Oh, y'all keep doing, y'all are doing great, keep it up.